So previous video we talked about a set of vectors linearly dependent, linearly independent. But this video gonna be how we gonna find the set of vector is linearly independent and linearly dependent in a special ways. Here is a couple of ways to you determine if the set of vectors is linearly dependent or linearly independent. First one is one vector. There is only one vector. The vector is not zero. We're gonna say vector V is linearly independent. For example, guys, vector is not zero, guys, okay? So V is gonna be, let's say vector is gonna be 1 and 0. So this one is a C1V1 equals 0, meaning is a C1, 1 and 0. So C1, 0 should be 0 vector, which meaning is C1 should be 0, right? So that case is V vector is linearly independent, right? Vector 1 vector is independent, gonna be vector should not be 0. When you have two vectors is linearly dependent, the meaning is gonna be another V2 vector is CV1. Any scalar multiplication, that's gonna be V1, V2 is linearly independent. Let's say, guys, give the example is V2 gonna be 2V1. Okay, so we have to show x1 V1 plus x2 V2 should be 0, right? That's x1, x2 is not trivial solution, that's the linearly independent. Non-trivial solution, that's the linearly dependent. But when you see this one, guys, here is 2v1 minus v2 equals 0. Can you see that? x1 is 2, x2 is negative 1. So x is a solution gonna be 2 and negative 1. This is non-trivial solution. So we're gonna say V1, V2 is linearly independent, guys, okay? So more than two vectors. So here is how many vectors here? V1, V2, Vp. Here is a p-value, guys, a p-value. So p is number of vectors in the set. Here is n. Here is n's r. So when you see number of vectors is v, the r of n's gonna be n. Number of vectors is greater than n, that's gonna be this set of vectors is linearly independent, guys, okay? We're gonna have example about this determination of linearly independent. So first one is u vector. U vector is right here, 1, 2, negative 4. U vector is non-zero. So we're gonna say u vector is linearly independent. Okay, let's go UMV. UMV. So that's gonna be scalar multiply of U vector. Can you say V vector gonna be, can you say V vector gonna be C times U vector? Let's make sense or not? C, 1, 2, negative 4. That's gonna be 2, 2C, negative 4C. That's gonna be same 2, negative 6, 2 and 3. Let's check it. So here is the C, guys, okay? C is negative 6, that's first one. 2C is 2, negative 4C equals 3. This is true or false, guys? Look at that. C equals negative 6, second one is C equals 1. It doesn't make any sense, right? It doesn't make any sense. So you're going to say this one is linearly independent. Okay, let's go three vectors. Okay, let's go here. What do you have? Check it, guys. You have non-trivial solutions. So you're going to have 1, 2, negative 4, negative 6, 2, and 3, 0, negative 4, and 0. And here is 0 and 0 and 0. This should be non-trivial solution. Can you do that, guys? Law operation one more time. Let's do the raw operation, guys. Okay, so here is you need, what you need here, negative 2R1. So negative 2, 12, Here is 0 and 0, so negative 2R1 plus R2 gonna be R, what is it, R2. Okay, so what is gonna be third row? You need negative 4R1, go to here, 4, negative 24, here is gonna be 0 and 0, so 4R1 plus R3, go to the R3. So you have this one. Let's see, this one is 1, negative 6 and 0, and 0, 0, 14, negative 4 and 0. Here is 0, negative. Here is, what is the number here? I can really see it. Here is a 3, right? Negative 21, 0, and 0. If you don't see that, so what are you gonna do? I'm gonna do here, this guy gonna be divide by 1 over 21, negative 1 over 21 R3. That's the negative 1 over 21 R3. That's how I'm going to do it, guys. So 1, negative 6 and 0, and 0, 0, 14, negative 4 and 0, 0, negative 1, 0, and 0. So I'm going to switch it, R2 and R3. Oh, I'm going to have negative here is a positive, right? So here is 1, negative 6 and 0, and 0, 0, 1, 0, 0, 0, 14, negative 4 and 0. You're going to pivot this 1. Here is negative 14. You need it, right? So negative 14, R2, 0, negative 14, 0, and 0. So you have new augment matrix. 1, negative 6 and 0 and 0, 0, 1, 0 and 0. What is the last one, guys? Here, negative 14, R2 plus R3. So we have 0 and 0, negative 4 and 0. Let's find it, right, guys? So let's see. This one is one more time. You have negative 1 fourth R3, go to R3. So you have 1, negative 6 and 0, and 0, 0, 1, 0, and 0, 0, 0, 1, 0. So another way, there is no free variable, okay? Every row has a pivot. So this one is you conclude U1, U, V, W, these vectors are linearly independent. Guys, make sense? Okay, that's the third part. Fourth part, here is how many vectors here? Guys, 1, 2, 3 vectors. 4 vector, P is 4. What is the element? Here it is. Where is this vector gonna be? R3. Entry is 3. So N is 3. This one is bigger, which meaning is U, V, W, G are linearly dependent.